So hello everyone and welcome to a new video. In today's video we are going to talk about linked lists. So before we dive into it, let's see what a linked list really is. So a linked list is a linear data structure similar to an array. However, unlike arrays, elements are not stored in a particular memory location. Rather, each element is a separate object that contains a pointer or a link to the next object in the list. Each element, commonly called nodes, contains two items, the data stored and a link to the next node. As you can see on the screen, the entry point to a linked list is called the head. The head is a reference to the first node in the linked list. Now that you have a basic understanding of what the linked list is, let's jump and code one. We'll start by defining a class for each node in our list. Each node will have two properties, data and next. Data will be basically the data that we want to store inside the node. It can be any data type that is accepted. And the next will be a link to the next node in the list. Yeah, we can go ahead and create a linked list class that will store our list. Inside the constructor, we'll define two properties, head, that will be basically the first node in the list, and the size of the list. The first operation we'll want to define will be adding an element. The add function will have a data parameter that will basically be the content of the node. The first thing we want to do here is create a new node with the data that we got. Now we need to check if the list is empty. We can achieve that by checking if the head property is not null. If the head is null, so the list is empty, we'll initialize the head with the node we just created. If the list is not empty, so we have other nodes in the list, we'll go through them one by one and add our node at the end of the list. To do that, we'll start with a head node, that's basically the first node in the list, and using the next property of the node, we'll jump to the next node and so on until the next property of the node we are in is null. So when we get to the last node, we'll just link the next property to the node we just created, and don't forget to increase the size of the list. Now let's go ahead and play with it a little. Go and create a new linked list. We'll use the method we just created and add some elements to the list. Now let's console log the list and see if it looks okay. As we can see, the size is 2 and the first node, it's the head node, and the next property is linked to the next node, so it looks okay. Now moving on, the next function we are going to implement, we remove the first element with a specific content. The approach here is similar with the add function. We'll basically iterate through each node and see if we found the node we want to remove and remove it. But besides the current node, we also need a previous node so we can link the nodes back together if we remove the current node. So as I said, we'll use a while loop to iterate through each node of the list. If we find the node we want to remove, we have two scenarios. The node is the first one in the list, so we override the head property, or it's another node and we just set the previous node next property to the current node next property. So we basically skip the current node. Now we want to decrease the size of the list and return the node content. Now outside the if statement, if we haven't found the node we are looking for, we just go to the next node and set the previous node to the current one. Time to test. Let's add another element. Now let's try and remove the node with the value 6. When we run the program, we see that the node was removed successfully and the list was updated. The next method we are going to implement is called indexOf, and will return the position of the first element with a specific content. We'll use a count variable that will basically be incremented each time we go to the next element. And a variable called current to store the current node. We'll iterate through each node, and if we find a node with the same data that we are looking for, we are just gonna return the current position we are in. If not, we are gonna increment the count variable and move to the next node. Finally, if we haven't found the desired element, we'll just return -1. Now it's time to test. Let's return the position of the element 45. As we can see, index 1 is correct because we are started counting from 0. Let's move the console log after the remove element function so you can see properly what I'm talking about. Now let's move on and define two simple functions. The first one is called isEmpty, and we'll check if the size of our list is equal to 0 or not. And the other one is called size, and we'll return our size property. Let's now jump to our testing area and call those functions quickly to check if they are working properly. As we can see, we got an error because we called the function size the same as our class property. So we'll just add an underscore before size. Okay, so we'll access it using this dot underscore size. This way we can name our function size. Now I'll quickly go and rename the variable across our code. If we run again now, we can see that the results are correct. IsEmpty is equal to false and the size is 2. Let's now define another function called firstElement that will basically return the first element of our list. We can do that by accessing the head property, but before that we must check if the head property is defined. If not, that means the list is empty. So if it is not empty, we'll just return this.head.data. This will contain the data of our first element of the list. And let's quickly console log our first element. As we can see, the result is correct. We made the first element, let's now make the last element. As before, we'll check if the list is empty, and if so, we'll return null. To get the last element, we'll just iterate through the list, and when we get to the end, we'll just return that element. Let's jump to our testing area and call the function. As we can see, we made a little mistake. In our while, we should go until the current.next is not null, because this way we'll stop to our last element. If we run now, we see that we get our last element of the list. You can play with the notions you learned today and implement more functions that will help you manipulate this linked list. You can go and inspire from the array. So that was it for today, guys. Don't forget to subscribe and like this video. See you next time.